Parametric equations are actually equations where we already know usually we have two variables. Parametric equations are just equations that are expressed separately because of a third variable, and very often it is expressed in terms of time. Time is a measurement that we do very often in experiments, and for example, if I have x equals to ft, y equals to ft, this is a set of parametric equation. So we give you two specific examples. So x equals to 2t plus 3, y equals to t squared. This is a set of parametric equation. And we are now going to try to see how we could manipulate it such that we obtain a Cartesian equation. Remembering that a Cartesian equation is in terms of x and y because we plot them on the x and y axis, on the x and y Cartesian coordinate. So how do we put these two parametric equations together to obtain its Cartesian form? Let's look at the next slide. In this example, we are going to be looking for the Cartesian equation of a set of parametric equations. So we want to just write one equation in terms of x and y only without the t variable. So of course we set the first equation to be x equals to 2t squared, second equation y equals to 1 minus t. We do a substitution. We put t to be the subject and we have it substituted into equation 1, and that's how we obtain just an equation that is expressed in terms of x and y only, and we call this the Cartesian form. So if we are to look at this equation carefully, we'll notice that this is actually a parabola. We shall now find the Cartesian equation of this set of parametric equation, and we notice that this set of parametric equation is of a trigo form, and because of that we need to use a trigo identity as such to help us replace or to give us the relationships between the x and the y's. So I am going to rewrite both equations in terms of, we're going to substitute secant theta as x and of course tangent theta as y, place it into the identity, and tada, that's the Cartesian form that you have. And very importantly, actually, we want to link this to what we learned previously. We notice that this is a hyperbola standard form and its center is 0, 0. We learned how to obtain the value of c, which is then the distance between the center to the two foci. And of course, we also did discuss how to obtain the equation of the asymptote. And by rewriting this in a Cartesian form, it also means now that we can plot this, we can plot a set of parametric equation if we know what its Cartesian form is on our Cartesian coordinate. And this is exactly the shape of the hyperbola that we've discussed before.